Before we get into the pipeline, let me give you a quick introduction to Jenkins. Jenkins is an open-source automation server and one of the most popular tools for continuous integration and continuous delivery, or simply CI/CD. Instead of building, testing, and deploying applications by hand, Jenkins takes care of those tasks automatically. Every code change goes through the same workflow, making the entire process consistent, reliable, and repeatable. A Jenkins pipeline is made up of multiple stages, and each stage has a specific job, whether it's compiling the application, running automated tests, performing security scans, or deploying the software. The goal is simple: catch problems as early as possible and automate the entire software delivery process. In this video, I'm not showing you a demo pipeline from a tutorial. Instead, I'll take you behind the scenes of the backend pipeline I use in my own Spring Boot project. We'll go through every stage together, talk about what it does, and explain why I designed it this way. Everything starts in my local Docker environment. This is where I develop new features, fix bugs, and test every change before it ever reaches Jenkins. Docker allows me to run all the required services, including Spring Boot, PostgreSQL, and Keycloak, in a fully reproducible environment. As a result, my local setup is already very close to the production environment. Once everything has been tested successfully on my machine, it's time for the next step. From there, Jenkins automatically builds, tests, and deploys the application to my Linux server. All of the quality checks are performed before the deployment takes place, ensuring that only tested and reproducible code makes it into the target environment. Now that you have a high-level overview of the workflow, let's jump into the practical part. Before Jenkins takes over, everything happens locally inside Docker. That's the environment I'd like to show you first. As you can see, all of the platform's core services, Spring Boot, PostgreSQL, and Keycloak, are already running as Docker containers on my development machine. The idea is to validate every new feature locally before Jenkins automatically takes over and deploys the application to the Linux server. Here's my local development environment. Every required component is already running inside Docker, which allows me to develop and test the application under conditions that are almost identical to production. This is the first stage of my development workflow. The goal is to automate the entire build process, run all tests and security checks, perform a local deployment, and then do one final manual verification. Only after all of that has been completed successfully do I deploy the application to the Linux server. The pipeline begins with the download source code stage. During this stage, Jenkins connects to my GitHub repository and automatically downloads the latest version of the source code. This ensures that every build starts from a well-defined and up-to-date code base. In the build log, we can see Jenkins cloning the repository and preparing the workspace for the rest of the pipeline. Only after this step has completed successfully does the actual build pipeline begin. Next comes the prepare build environment stage. This is where everything is set up for the build process. Jenkins prepares the workspace, verifies that all required tools are available, and makes sure the build environment is clean and fully reproducible. This guarantees that every test and analysis later in the pipeline runs under exactly the same conditions. Once the source code has been downloaded and the build environment is ready, Jenkins automatically starts the unit tests. Unit tests verify the smallest functional parts of an application, such as individual classes or methods. Their purpose is to catch bugs as early as possible, long before the application is packaged or deployed. In my project, all unit tests are executed automatically using Maven. The pipeline continues only if every single test passes. If even one test fails at this early stage, the build stops immediately. This prevents faulty code from moving on to the remaining build and testing stages. The next stage is API testing. Unlike unit tests, API tests don't verify individual classes or methods. Instead, they validate the application's REST APIs. The tests send HTTP requests to the API and verify that the expected status codes and responses are returned. This ensures that the application's core functionality works reliably from a client's perspective. All API tests are fully automated, and the pipeline continues only after every test has passed successfully. Next, Jenkins extends the quality assurance process with automated security tests. During this stage, the application's core security features are verified automatically. This includes authentication, authorization, and access to protected REST endpoints. These tests ensure that only authorized users can access sensitive resources and that security-related changes don't introduce unintended vulnerabilities. By running these checks automatically, security issues are identified during development instead of after the application reaches production. The next stage is integration testing. While unit tests and API tests focus on individual components or interfaces, integration tests verify how the entire application works together. For these tests, I use Testcontainers. The required services, such as a PostgreSQL database, are started automatically inside Docker containers. Each test runs in a completely isolated and reproducible environment, and once the tests are finished, the containers are removed automatically. This provides a major advantage. Integration tests run under realistic conditions without requiring permanently installed local databases or other supporting services. As a result, I can reliably verify the interaction between Spring Boot, the database, and all other components involved. Next up, Jenkins prepares the application for the remaining stages of the pipeline. At this point, Jenkins compiles the source code and packages it into an executable Spring Boot jar file. At the same time, it archives all build outputs and test artifacts generated during the build. These include test reports, build metadata, and other files that are needed for the remaining pipeline stages or for future analysis. By archiving these artifacts, every build remains fully traceable. Whenever needed, the results can be reviewed, analyzed, or compared with previous builds. By the end of this stage, the application has been successfully built and is ready for the next round of quality, security, and performance checks. Next up is SonarQube, one of the most valuable tools in the entire pipeline. At this stage, SonarQube automatically scans the complete source code. It looks for potential bugs, security vulnerabilities, code smells, duplicate code, and also measures your overall test coverage. The idea is to catch quality issues long before the application gets anywhere near deployment. Fixing problems early is much faster, much cheaper, and a whole lot easier than dealing with them later in production. That's exactly why SonarQube is a core part of modern CI/CD pipelines. It helps developers continuously deliver code that's clean, maintainable, secure, and ready for production with every single build. Next up, Jenkins hands the code over to SonarQube for a full quality analysis. SonarQube automatically scans the entire codebase, looking for potential bugs, security vulnerabilities, code smells, duplicated code, and it also measures your overall test coverage. The goal is to catch quality issues as early as possible, before the application gets anywhere near deployment. Finding problems at this stage means they're much easier, faster, and less expensive to fix. That's why SonarQube is such an important part of modern CI/CD pipelines. It helps developers consistently deliver code that's clean, maintainable, secure, and ready for production. The next step is the SonarQube quality gate. At this point, Jenkins waits for the SonarQube analysis to finish before moving on. The quality gate defines a set of quality standards that the application has to meet. These include metrics such as the number of bugs, security issues, code smells, and overall test coverage. The pipeline continues only if all of these requirements are met. If the quality gate fails, the build is stopped automatically, preventing a low-quality version from moving on to the next stage of the pipeline. In this build, the application passed the quality gate successfully, so Jenkins can continue with the remaining stages of the pipeline. Next up, Jenkins checks every library your application depends on for known security vulnerabilities. Using OWASP Dependency-Check, it compares all of your project's dependencies against a global database of publicly disclosed security issues. If any critical vulnerabilities are found, Jenkins can stop the pipeline automatically. That way, vulnerable software never makes it to the next stage, or worse, into production. Once everything gets the green light, Jenkins automatically deploys the application to the local Docker environment, where it's ready for the next round of testing. During this stage, Jenkins verifies the configuration, gracefully shuts down any existing containers, and restarts the application with the latest changes. This local deployment allows me to test the application under realistic conditions before it's deployed to the production server. That way, any issues can be identified early and fixed before they ever reach production. Once the application has been deployed locally, Jenkins immediately runs a Docker smoke test. This is a quick sanity check to make sure everything started up correctly and that the application's core features are working. That includes the health checks, the REST API endpoints, and the connection to Keycloak. Within just a few seconds, The smoke test tells us whether the application is basically healthy and ready to move on. If everything looks good, Jenkins continues with the rest of the pipeline. The final step of the local quality assurance process is automated performance testing with K6. These tests evaluate how the application behaves under load. Multiple virtual users send requests to the API simultaneously, allowing response times, stability, and potential bottlenecks to be measured. The results are then archived as an HTML report and stored in Jenkins for later analysis. This makes it easy to verify that the application continues to perform reliably even under heavier workloads. The performance tests completed successfully. A total of 1,355,809 requests were processed without a single error. Both the stress test and the spike test stayed well below the defined thresholds, demonstrating that the application remains stable, fast, and reliable even under heavy load. In addition, Jenkins runs a static code analysis using SpotBugs. SpotBugs searches the source code for common programming mistakes and coding patterns that could lead to future problems. In this build, only one medium priority warning was found. It isn't a critical issue, just a recommendation for improving the source code. No high priority warnings were detected, indicating that the overall code quality is very high. The OWASP Dependency-Check report confirms the results of the earlier security scan. A total of 158 libraries were analyzed, and no known security vulnerabilities, CVEs, or vulnerable dependencies were found. This confirms that all open-source components used by the application were up to date and secure at the time of the build, helping identify and eliminate known security risks before deployment. Another important quality metric is test coverage. The JaCoCo report shows which classes and methods were actually executed by the automated test suite. In this project, 97% of all instructions and 88% of all branches are covered by automated tests, with many core components reaching 100% test coverage. This high level of coverage allows code changes to be validated quickly while significantly reducing the risk of introducing undetected bugs. A reliable build doesn't end when the application compiles successfully. Only after quality, security, and performance have all been verified automatically is the software ready for the next step. In Part 2, I'll show you how the application is automatically deployed to the production server.